Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video, we'll continue to learn about pre-processing in scikit-learn. And we'll begin on a new topic called imputation of missing values. And this particular video will focus on univariate feature imputation. So we'll begin with looking at what missing values are and what is imputation. And then we'll look at the intuition behind what is univariate imputation, and I'll walk you through what the notation CSR and CSC means. And finally, I'll show a code snippet before getting into Jupyter Notebook to do the actual coding. So, what are missing values? And you've probably guessed it. The missing values are the values that are not present in the data set. Let's say, for example, here we have a data set with two features, feature 1 and feature 2 in each of the columns. And the NaNs indicate that the values are missing. So in feature 1, we have one NaN in the second row, and in feature 2, we have NaN in the third row. So this is an example of numeric missing values. And here below that, I've put calculated the mean. So the mean excludes the missing values. And here we have the mean of 3 for the first column and the mean of 2 for the second column. And the reason why the mean is calculated is because we can use that in place of the missing values. So that's called imputation. So when we are replacing the missing value by any other value, the word is used here is imputation. And the values that we can impute, or the values that we can put in place of missing values, could be as simple as a 0, or it could be a mean of that feature column, a median of that feature column, or the most frequent number or most frequent value of that feature column. Additionally, there are more sophisticated methods as well, as we'll see in coming videos, where other features can be used to predict the missing values in a particular feature. So here we are looking at univariate imputation, and so we'll look at features that are used to impute values that are missing in that feature only. So here, the general method is we would fit a model on the data set that this could be the training data set, and that would have the missing values. And then when we transform the data set, and when then we transform a new data set. For example, here we have a new data set which also has two missing values in feature 1 and 2 highlighted by yellow. When we transform that data set, we can go ahead and substitute the mean values. If we do a mean imputation, we can substitute the mean values in each of those NaNs in those each of those two features. So the feature 1 has a mean of 3, and that is substituted in the missing value for feature 1. Feature 2 has a mean value of 2, and that is substituted here in feature 2 after it is transformed. So that is how the imputation works in this case. So now moving on, let's look at what are categorical missing values. And as you can see in this figure, the values that the each of the two columns have the letters A, B, C, or D, and there are no numeric values in these two columns. So these are this could be the categorical, this could be categorical data. And if there are missing values within such columns, then those would be the categorical missing values. And to one way to replace the miss or impute the missing values in such a data set is by using the most frequent values. So here in column A, the most frequent value is A. Column 1, the most frequent value is A, and column 2, the most frequent value is B. So if we go ahead and apply the fit transform to that data set, we can substitute the missing values by the letter A in feature 1 and letter B in feature 2. So what is univariate imputation then? We've already seen the example where if we have two features such as shown here, feature 1 and 2 with missing values highlighted in yellow, then we can compute a mean for each of those features and use those values from that feature itself to replace the missing values in that feature. So we'll use the 3 to replace the NANs there, and thus we have those means added there. So that is univariate imputation, where we do not use data from other features to impute a missing value in another feature. So we use the data from that feature to replace missing values in the same feature. So there's no crosstalk between features when we are doing the imputation. Finally, because we look at this during coding, I just want to mention this. What is CSR and CSC matrix? So CSR stands for compressed sparse row matrix, and the notation is as shown here. Let's say we have a matrix 3 by 2 matrix as shown here on the left. Now in CSR notation, the way this is written is we go through the matrix or array row wise. So first non-zero value is 1 and it is at index 0 0, so we have 0 0 which is at 1. Then the next value is 2 which is at index 0 1, and therefore we have that here. And then we have a 0, so we exclude the 0 and move on to the -1. So -1 is at index 1 1, and that's what we have, and so on for the rest of the matrix. So that's notation used for CSR. Similarly, there is a notation called CSC, which is compressed sparse column matrix. And for column matrix, we have 0, 1 is at 0 0, which is the same. But then now we are going to travel along the column. So then the 0, we ignore that. And then we look at 4. So 4 is at index 0 1 2, so it is at index 2 0, and that's what we get here. And similar, next we move on to this 2, and this is at index 0 1, and that's what we have right here. So the reason why I brought up this notation is because we'll see that when we are using the imputation, the it's possible to work with a CSR or CSC dataset type of data structure as well. And here is the slide on code snippet. The method of implementation is very straightforward. We first import the libraries, and this is to show a simple imputer. There are other imputers as we'll see in coming videos. So first we have our data set. This could be the training data set. And then the strategy, I should have comment there because we don't want to run this column, run this line on strategy. So there are different strategies. There is a mean, median, most frequent, and constant. So for implementing this, we would initialize the variable imp is equal to simple imputer, and then here missing values is equal to, here we specify what needs to be considered a missing value. So here if we put np.nan, then those values would be imputed. If we go ahead and specify -1, then the -1 values in the dataset would get replaced or imputed. And then strategy is default here is used as mean, but we can go use either of these strategies as needed in this simple imputer case. And once that is initialized, we can perform a fit on a data and then use that model imp to transform a data set, which would give a resultant data set which would have imputed values in it. thus getting the missing values replaced. Now let's get into Jupyter Notebook and see this in action. So here I've imported two libraries so far, NumPy and preprocessing from sklearn. Next, we need to import some specific libraries. So let's do that. We'll import from sklearn dot impute. We need to import simple imputer. So import simple imputer, and additionally we'll also import the sparse. So from import scipy.sparse as sp. So we'll need that when we work with the CSC or CSR metrics. And these are the versions of the Jupyter notebook that I'm using. Now for the univariate, so we are today going to work with univariate in this video. So for univariate, we will first create an array as our data set. So np.array, and this is going to be a small array where we have 1 and 2 in the first row, and then we'll create nan value, so missing value in the second row, and finally we have a missing value in the third row as well. So we have nan there. So that's our data set. Now, as we've seen earlier in the code snippet, we'll initialize imp is equal to simple imputer, and then specify the missing values as np.nan, and the strategy we'll use is mean. Now once this is run, here we can go ahead and do the fit also, imp.fit x, and then we run this. We see that it returns that object, and then now we could go ahead and apply it to the array x. So we could say imp.transform x, and we'll get the imputed values, which are the means. So the mean of these first two is 5 plus 1 is 6, and so the mean is 3 divided by, and that's what we get here. And for the second one, the mean is 2, and that's what we get here. Now instead of transforming the existing x dataset which we used for fitting, we can go ahead and create a new dataset which has missing values, and let's see how that gets transformed. So we have this array nm where we have missing value in the first row, and then we are going to create missing value in the second row as well, and finally we have the third row which does not have any missing value. So we have 11 and 12 in there. And now when we run this, that's our original array with missing values in the first and second row, which we need to impute. So now we can use the imp that we have created earlier and then transform m. And as you can see here, we replace the nans with the mean values for those features. So here in this particular x, we had feature 1 which is column 1, feature 2 which is column 2, and for feature 1 the mean value was 3, and feature 2 the mean value was 2, and so those got imputed here. So 3 and 2 for each of those two columns. So that was how we can use a simple imputer. Moving on, now let's look at how we can use the simple imputer with CSC type of matrix. And here we can go ahead and create a new array. So let's create an array x np.array, and this will be a 3 by 2 matrix. So we have 1 2, and then the next one we have 0 minus 1, and finally we have 4 and 8. So if we print this, so this is the array that we have, and in this particular array we can calculate the mean of this one. So let's see. np dot mean and x, and we'll get the mean on x is 0. So this is the mean we have. So here we have this mean which is based on the three values, but on the right hand side there is the -1, which we are going to use as a missing value that needs to be imputed. So the actual mean in this right hand side column is 2 plus 8 plus 2 divided by 2, so 5 instead of 3 that we got here, because that considers this -1 in the calculation. Now we'll create a CSC matrix. So we'll use the X matrix that we have above and use the sparse library that we imported earlier, sp.csc underscore matrix and X. Now if we print X, xc, and we'll see here. So this is the way we have this written. As we saw in the previous slides, 1 is at 0 0, then we go down the column and we have 4 at 2 0 index. So the method of imputation is the same. We initialize the variable imp using simple imputer, and here we can specify what needs to be considered as a missing value. We are saying it is -1, and then we have strategy is equal to mean, which is the same as what we used before as well. And then we can perform the fit. So imp.fit, and we'll fit this on xc this time. So once this is fit, let's see what the error is. Okay, so this needs to be missing values. Sorry. Okay, so we have this set. Now let's go ahead and create an array M that we can use for transformation. So np.array, and this again is a 3 by 2 matrix with -1, which is the missing value we are going to use in this transformation, and the second row also has a -1, and finally we have the third row which does not have any missing values or -1s. So now we can use the uh, IMP that we created up above to transform this. Before we do that, we'll convert this to CSC matrix. So CSC underscore matrix M, and now we can let's print this. So why don't we do that? We can go ahead and print this. So that's our matrix that we are looking to transform, and we can now go ahead and use imp dot transform, and here we can use MC, and to get the output we need to convert it to array, and we'll also, let's see what we get. Okay, so as you can see, the mean value that we calculated earlier, it was 1.667 for feature 1, that is column 1, and that got replaced right here in this in place of -1. And then for the second column, uh, the mean was 2 plus 8 10 divided by 2, that's 5. And so this -1 got replaced by 5, which is the mean value. Now moving on, let's look at how we can uh, impute the values in categorical variables. So let's create a data frame, and in this data frame we are going to uh, create some missing values. So we need pandas library, so we'll go ahead and import that as pd, and let's create a data frame. Df is equal to pd dot data frame, and here here we have the column A, the first column, and then this is the second column. Moving on, we have now missing value in the first column, and then the letter B in the second one. and so on. For the third column, we put A and np.nan, and finally we put C, D, and then let's create one more. Uh, well, maybe that's enough. So we have four of them, and then uh, we need to add the data type. So let's say this is data type is category. Okay. So now when we run df, that's the data frame we have. And we are trying to impute these values. And if you remember from the slides, there is a strategy called most frequent, and we'll use that in this case. So we'll continue to use a simple imputer, and the strategy we'll use is most frequent. And once we have that, we can fit that imp.fit fit transform. We could write fit and transform in separate lines, or we could do it this way. And as you can see in the output array, we have the missing value from the second row in the first column replaced by A, because A appears two times and C appears only once. Similarly, in the second column, B appears two times, D appears only once, and therefore this NaN is replaced by B and not D. That was it for this video. I hope in this video you got an intuition around what are missing values, what is what is imputation, and how imputation works in case of univariate data type. And finally, we'll look at simple imputer in different cases, which is simple arrays or CSC matrix or a data frame. And we looked at two strategies, mean and most frequent. So in the next video, we'll look at the multivariate type of imputation and see how that works. Until then, please like, share, and subscribe. I hope to see you all in the next video. Thank you.